This video was produced by Vivonix. The following images may be disturbing to some viewers. Discretion is advised. Vivonix is creating Patient, the physical anatomical trainer instrumented for education and non-subjective testing. Patient is a highly modular mannequin that provides realistic and quantifiable training for surgical and other medical procedures. The ideal medical training mannequin would present both physical realism and systemic body reactions, utilize reusable components and sufficiently inexpensive disposable components that the system can be used by many trainees and remain cost-effective. Patient is designed with these conflicting needs in mind. Each organ is individually removable and replaceable so that disease states and injuries can be easily presented to the trainee. Patient is instrumented so that the flow and blood pressure in each organ is measured, and insults or incisions to each organ's capsule are recorded. Patient includes the following key components: solid and hollow organs with cut sensing instrumentation, realistic vasculature, an instrumented substrate, outer torso, and a clotting blood analog. The substrate, hidden under the patient torso, records the blood flow and pressure so that systemic responses can be accurately simulated. The forces associated with cutting the organ capsules, however, are too low to reliably record from instrumented tools or gloves. Therefore, each patient organ includes an active mesh made of fibers painted directly into the organ capsule. The mesh is seen here in an uncoated kidney. The mesh enables patient to record where an organ is cut. Patient also includes sensors that monitor the hemodynamic status of each organ. This is done invisibly to the user by employing instrumented junctions consisting of fluid and electrical connections at the junction of each organ to the vasculature. Using this combination of low-cost disposable and reusable components maintains a high functionality with low cost. The substrate also houses pumping components that simulate realistic blood flow. A reservoir of a blood analog feeds the peristaltic pump, which forces the blood through the instrumented junction and to the organs. The software records all data and creates realistic whole-body reactions. Incisions can be monitored by a test administrator. The grid on this screen, for example, corresponds to the active mesh that is embedded into the liver. When the liver is cut, the corresponding sections of the grid on the screen light up green. Pressure and flow are recorded and displayed for each instrumented junction. Here you can see an example surgery of excision of a tumor in a liver. In this preliminary test, the liver has been isolated from the patient mannequin. As the liver is cut, the software keeps track of the blood flow at inlets and outlets, the blood pressure, and also the incisions made. The blood analog used in the patient mannequin is the same as used in our instrumented hemorrhage trainer. This blood analog clots realistically when bandages with a clotting factor, sold with the mannequin, are applied. The patient training system is a suitable replacement for practicing surgical techniques without a cadaver. The system is also cost-effective compared to the cost of procurement of cadavers and other surgical training systems. Further refinements are planned, including a higher resolution mesh for finer spatial recognition of scalpel cut locations, and incorporating force and position sensing tools and gloves. For any further information on this or our other projects, don't hesitate to contact us.